Hey guys, so today we're looking at personal expenses and some graphs that go with them, and being able to read graphs based on personal expenses. So as a warm-up, we are again going to graph a line represented by this equation. So it's already in the form y equals mx plus b, but we see that it needs to be flipped around a little bit, so it's y equals 2x minus 3, okay? So again, the slope is going to be whatever's multiplied by x. So the slope is going to be 2 here. And then we're going to put it over 1 in order to have it as a fraction, so we can read it as rise over run. Okay, and then the y-intercept is going to be whatever's added or subtracted to the end when it's on this form. And we just have a negative 3. So I'm going to go ahead and say that this is 1, 2, 3, and do it like that. So every other one, because this kind of has a little bit of a weird layout. Okay, so y-intercept is negative 3. Start with the y-intercept. You count down 3 in order to put our point there because it's negative. And then using the slope, we're going to go up 2 and over 1. So up 2 and over 1. Up 2 and over 1. And now that we've got a couple points graphed, we can go ahead and connect the dots to make this beautiful graph. And then, again, draw the arrows on either side. So since the slope was positive, you can see that it's pointing upward. So as this part increases as well. And then since it has a negative y-intercept, it hits the y-axis below the origin. And then on part B, again for a warm-up, it says to find the slope and y-intercept of the line 70 equals negative 2y plus 8x. So we need this to be in the form y equals mx plus b. So we need to solve for y. So if we take 70 minus 2y plus 8x, in order to solve for y, we need to get y on its own. So we'll subtract this 70 to do the other side. I just realized I did not put an equal sign there. So instead of subtracting 70, let me make sure I'm copying the problem down right first. We are going to get the 8x to the other side because we need y on its own. So we have the 70 minus 8x is equal to this 2y. But again, we don't want to know what 2y equals. We want to know what y equals. So we'll divide everything on here by 2, which will give us that y is equal to whatever we get over here, 35 minus 4x. But again, we need to flip these two around to get y equals negative 4x plus 35. So the slope, now that we have it in this y equals mx plus b, is going to be the m. So the slope is this part that's multiplied by x, or the coefficient on x. So the slope is negative 4. And then the y-intercept is this b part, so whatever's added to the end. So we have this 35. So the slope is negative 4, and the y-intercept is this 0, 35, because you don't go left or right any, and then you go up 35 to find that point. So in this section, you're going to be learning how to find patterns in data about personal spending. You will do this both graphically and algebraically. The data that we've been working with so far has been all single sets of numbers, so you only have one number to look at, and that's called univariate data. So one variable is all that means. So just like a unicycle has one wheel, univariate means one variable. For example, when a person keeps a list of weekly expenses, the data in the list are univariate data. All you would have is how much they spent on whatever, how much they spent each time they spent money. Using univariate data, you can find measures of central tendency, which are things like mean, median, and mode, which we looked at before, and different measures of spread, or how spread out the data is. So like range, variance, or standard deviation. So those are all things that we've looked at so far. But sometimes data is collected and represented in pairs. Okay, so data represented by pairs of numbers that could possibly show a relationship between the numbers that are paired together is called bivariate data. So again, there are two pieces, or two variables, or two pieces of data that you're looking at here. For example, if you keep a list of the days of the month and the amount of disposable money left from your monthly allowance, the set would be bivariate because you're looking at the day along with the amount of money left over. So because you have two different things you're looking at together, then it's bivariate data. So, going to the next page, a scatter plot is a graph that shows bivariate data using points on a graph. So we literally take each pair and you will use them as coordinates on a graph. Scatter plots may show a general pattern or a trend within the data. A trend is just a relationship between two variables. A trend may show a correlation. Or association between two variables. Okay? So a positive correlation exists if when one of the pieces of data, one variable, increases when the value of the other variable increases. And a negative correlation exists if the value of one variable decreases when the value of the other variable increases. So if you're looking at a positive correlation and you graph it, you're going to have a positive slope. And if you're looking at a negative correlation, you're going to have a negative slope. Because as this goes positive here, this is getting more positive. And as this gets positive, you can see that this one, the up and down, is actually going downward. Okay? So, moving on, a trend may also show a causal relationship. Which means that one variable actually caused a change in the other variable. The variable that causes the change in the other variable is called the explanatory variable. Explanatory variable. And then the affected variable is the response variable. While a trend may indicate a correlation or a causal relationship, it doesn't have to. If two variables are correlated, and it doesn't necessarily mean that one caused the other. So correlation does not mean causation. Just because two things correlate or have a relationship between one another, it doesn't mean that one variable caused the other to increase or decrease. So looking at example 1 from the book, it says, Elijah is a 16-year-old high school student who has a part-time job after school. He is looking to see if there are any trends that relate monthly income to monthly clothing purchases among his high school peers. So he wonders if possibly if you make more money a month, you spend more money on clothes a month. Or maybe vice versa, the opposite, however you want to look at it. He thinks that these two variables might be related. So he wants to use a scatter plot to investigate. Below is a list of ordered pairs, x, y. So each one has a number, comma, a number, where the first number, x, is the monthly income, so how much money this person makes a month, and y represents the second number, how much they've spent on clothes for that month, for 10 of his classmates. So he's got 10 numbers here. So each one is the income, comma, clothes spending. Okay, so it says to construct a scatter plot below by hand. Okay, so we can go ahead and do the income on the x value, on the x-axis, and then the clothes spending on the y. And we're going to go ahead and fix some of these again. So we'll say that this one's 200, this one's 250, this one's 300, this one's 350, and then this one is 400. Okay? And I'm going to go ahead and erase these other ones just to make it a little easier to see what we're actually looking at. And then we will go ahead and change the axes labels on the side as well. So I'll go ahead and erase these. Okay. And now on the side we need up to about, looks like the highest number is about 80 something, so we'll go up to about 90 or 100. So we'll do 10, 20, 30, 40, 60, oops, sorry, 50, 60, 70, 80, 90, 100. So we'll just go by tens on those. Okay, so first one, 205,36. So a little over 200 and up to 36. Make our first point. 242,45. So about here. This is 200, this is 250, 242, 45 is about up here. It doesn't have to be perfect, just around the right place. 268.57, 268.57 will be about here. Okay. 296.63, almost 300 and up to 63. 303.69, so a little over 300 up to 69. 327.64, so past 325 and then up to 64. 339.75, so not quite to 350. 330 sums up here and then up to 75, halfway through those two. 344.80, so not quite 350 yet and up to 80. 355.82, so a little over 350 and up to about 82. And then lastly, 380, so up here almost 400, and then up to 84. So about the same right there. So now that we've constructed the scatter plot, or just plotted the points that we're given, do we actually see any correlation? And we wants us to explain. You can see that if you would kind of look at this, you'd have a line going about that way. Okay, since income is increasing as clothing spending is increasing, you can see that it's looking, the hill is going upward. It's got a positive slope. Since it's got a positive slope, there is a positive correlation because the points resemble a line with a positive slope. So because after you've graphed these, we get what looks like it could be a line with a positive slope, we have a positive correlation. So practice problem 1 says to use the scatter plot above that we looked on the last page. If a student has a monthly income of about $250, how much would you expect that he would spend on clothing a month? Okay, so we'll look about $250 and we'll go up and we'll see that it's in between $40 and $50. I'd say about $48. Okay, and we use the graph. Not since, sorry, by the graph. So with the graph that we've looked at, we can see that if we follow this line that looks about like it matches the points, then if you spend about $250, it'd be up to in between $40 and $50 spent on clothing, and I'd say more toward $50. So example 2, For many people, the cost of contact lenses is a discretionary expense. Okay, so it's not necessarily essential because they could wear their glasses. Henry buys contact lenses through an online retailer. He has found the type he needs is sold 6 lenses to a box. The retailer has a sliding price based on the number of boxes purchased, according to the following table. So, it says to create a scatter plot using this bivariate data. So we have the boxes and we have the price per lens. So again, I am going to go ahead and basically erase the numbers on this. Yours will not have this on it, so don't worry about it. I'll make sure that it's gone on yours. But I have to do it every time. Okay. So it says to go ahead and plot it using the X value is the number of boxes. So this one's going to be the number of boxes purchased. And the Y value is the price per lens. Okay. So here, the number of boxes goes up to 24. Okay, so the X value is the number of boxes. So it goes up to 24. So we'll go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, and then price per lens goes up to $6. So we'll go 1, 2, 3, 4, 5, 6. Okay, so our first one is going to be 1 box and $6. So at 1 box, about halfway, it's $6. Okay, 2 boxes is $5.90. So $2 is going to be almost 6, but not quite. 4 boxes is $5.40. So I'm about halfway almost there. 8 and $5.20. 8 is up to $5.20, so just a little over $5. 10 is $4.80. 10 is $4.80. 12 boxes is $4.10, so just a little over $4. 14 boxes is $3.80. Okay. 16 boxes is $3.10. 20 boxes is $2.50. So 2.5 here. And then 24 boxes is $1.70. Okay. So now it says, what do you notice about the number of boxes purchased and the price per lens? So if you buy more boxes, the more boxes you buy, so as the number of boxes goes up, the price goes down, so the cheaper the lenses. This is a negative correlation, because as one number goes up, the number of boxes, the other number goes down, it decreases the price. And you can actually see that if you'd kind of trace them, see if you're a little better at it than me, but you'd have a negative slope. It's going downhill. Okay, so is there an explanatory variable and a response variable? You know, is there a reason that this happens? So I think it is, and they do this on purpose. So the explanatory variable is going to be the number of boxes, because the number of boxes that you buy directly affects how much you pay for them. And so the response variable, the one that's affected, is going to be the price. Practice problem 2 says the basketball team at North Lane High School has been given permission to sell cold water bottles and hot chocolate to students as they walk into school each day as a part of a year-long fundraising event. So all year they're able to sell cold water bottles and hot chocolate. For the entire school year, the students keep track of the outside temperature along with the sales. 2 scatter plots were graphed, one for each drink, with temperature on the horizontal axis. So we'd have temperature on this, and then drink sales. Okay? And let's go ahead and do this for, we'll do both of them on the same graph. Okay? 2 scatter plots were graphed, one for each drink, with temperature on the horizontal axis, like I've got here. So which plot do you think showed a positive correlation? So if the temp is low, you'd think that more people, so you'd have more drink sales for hot chocolate, but as it gets hotter outside, less people will want hot chocolate. So that's the one for hot chocolate. That's my guess, because you would think if it's low temperature, it's cold outside, more people would want to buy hot chocolate. If it's hot outside, less people would want to buy hot chocolate. Well, if you're looking at cold water bottles, it'd be the exact opposite. If it's cold outside, not many people want to buy a cold water bottle. But if it's hot outside, more people would want to buy a cold water bottle. Okay? Which scatter plot do you think showed a positive correlation? I would think the cold water bottle. Because you can see here, where I've kind of sketched out the graphs, that it has a positive slope. As the temperature increases, drink sales would also increase. So as the temperature gets hotter, you would sell more cold water bottles. So example number 3. Tiana was looking at a chart that shows how teenagers spend their money and noticed that the percentage teens spend on personal care or cosmetics or accessories is about the same as the percentage that teens spend on shoes. She decided to pull all of the girls in 2 classes she has. She created the scatter plot below with the school year amount spent on personal care, cosmetics, and the school year amount spent on shoes as the variables. So this would be the cosmetics and the other things like that, accessories and such. And this would be shoes. What conclusions can you draw from this scatter plot? Okay, you can see. Does it show that the amount spent on personal care causes the amount spent on shoes? Okay, so what conclusions could you draw? People spend about as much on cosmetics as they do shoes. See, every one, they look to be almost the same. They spend about as much on cosmetics and personal care and stuff. I'm just going to put cosmetics as they do shoes. Okay. So we have a positive slope. It's going uphill, you can see. But that doesn't mean that the amount spent on personal care causes the amount spent on shoes. So it does not show causation. Just because the 2 things are correlated and they have this positive correlation does not mean that one causes the other. They are completely unrelated to one another. So just because you spend $50 on makeup or $50 on hair product doesn't mean that you automatically have to go out and spend $50 on shoes. That's all that means. It just so happens that the people that she surveyed spend about the same number or the same amount of money on both. It's purely coincidence and not necessarily related to that. It could be related to the fact that they have money for both, but it's not necessarily related to each other. Practice problem 3, I want you to try on your own. Think of an example of a negative correlation for which there's no actual causal relationship. So I want you to think of something that goes up when something else goes down, but it's not necessarily caused by each other. Now we can look at example 4. It says the scatter plot above shows the relationship between the number of coffee purchases. So this is going to be the number of coffee purchases made during a semester, and the grade point average. So over here is going to be the GPA for that semester for 10 different students. So we have the number of coffees they bought and their GPA. So describe any patterns you see in the data. Well, it doesn't really look like there's a line going on. There's no way you could just graph it and see that it hits most of the points. So if you graph it and it doesn't look like you've got a line, there are no patterns. And if there's no patterns in the graph that you've graphed, there's no correlation. So the number of coffees that these people have purchased has nothing to do with their GPA. And then lastly, practice problem 4. It says high school students collected data on the price of a cell phone purchase and the tax on that purchase. The students created a table of ordered pairs of these two amounts and planned to construct a scatter plot. So if you draw a little graph here, we would have the price of a cell phone, and then we'd have the amount taxed on that purchase. Should there be a positive correlation, a negative correlation, or no correlation? Okay, so the more that you pay, the more that you get taxed. So that would be a positive correlation. Because as price goes up, so as the price of the phone goes up or increases, the more taxes you pay on the purchase. So, since they both are increasing, you can see that it would be a positive slope or a positive correlation. And this is a direct cause because the taxes are just so much of a percent of what you pay for the phone. So let me know if you guys need any help on any of this. If you have any questions, go ahead and try the practice problems that should be posted soon. And let me know if you guys have any questions on that or need any help. Have a great day, and I will see you guys later.